Hi, I'm Len Groom, Technical Product Manager for Power Sports at Amsoil. I'm here in our mechanical test facility where we subject this 2012 Harley Street Bob to some of the most extreme heat testing imaginable. We tortured this motorcycle all in an effort to see if or when Amsoil's 20W50 motorcycle oil could fail. In order to test the limits of Amsoil's motorcycle oil, we needed the engine hot. So the first step is to eliminate the air moving across the cooling fins. These engines are air-cooled, so things heated up extremely quickly. Next, we disconnected all of the temperature safeguards that would normally protect this engine in the event somebody tried to overheat it. We attached a number of sensors all over this bike, everything from oil temperature to head temperature, exhaust gas temperature, right down to the RPM. We even set up a heat mapping camera so we could truly watch the heat unfold in real time. We programmed the dyno to simulate conditions that you would see maybe at a motorcycle rally, where there were periods of extended idling, extremely slow driving. Remember, we took all of the air cooling away from this engine, so it wasn't long before we started seeing some extreme temperatures. The temperatures began to rise extremely quickly. In this shot from the heat imaging camera, you can see that the temperatures in the upper cylinder and the lower head region were 430 degrees Fahrenheit. Now you have to remember, average temperature in a motorcycle in normal riding conditions is somewhere around 280 to 300 degrees Fahrenheit. We're well above that. The temperatures continue to climb, and in this photo, the temperatures in that same region are now hitting 450 degrees and still climbing. This analysis image shows that temperatures reached an unbelievable 550 degrees. The heat involved with this test was so extreme that we actually melted a couple of low oil pressure sensors out of this bike. We replaced the sensors and kept running the test at these extremely high temperatures. Once done, we drained the oil and took samples. The oil that came out of the engine was so hot, we actually had to use Pyrex glass beakers for the samples because our standard plastic sample bottles were melting. As you can see in the footage, the oil was literally smoking when it left the engine. Due to the extreme heat produced during this test, the metal of the engine expanded to a point that when we took the oil filter off, the stud that generally stays in the engine came with it. We ran this test several times. Each time, everything was monitored and everything was documented. All of the oil samples were taken to the lab for analysis. Here's what we found. In this viscosity graph, you can see we show the oil before and after the test. Now the interesting thing is that the numbers are identical. That means that the viscosity of the oil was not affected by the extreme heat that we subjected it to. Typically, when the viscosity starts to drop, wear protection starts to become compromised. That was not the case with the Amsoil 20W50 motorcycle oil. In this oxidation graph, once again we show the oil before and after the test. And as you can see, Amsoil shows a very small oxidation number. When an oil starts to oxidize, normally the tendency to build deposits starts to rise. So you want to see the oxidation number low, which indicates that the oil can still keep the engine clean. Based on these numbers, our oil still has the ability to keep the engine clean even after we subjected it to insanely high heat. An oil's total base number is its ability to deal with acid from combustion. This graph shows that the Amsoil product has plenty of reserve capacity to deal with acid from combustion, even though we put it through that extreme heat cycle. In this graph of the wear metals, we can see that the numbers are extremely low, or in some cases, zero. What that indicates is that even though the oil was at extremely high temperatures, it was still doing its job to protect the critical parts of the engine. So what were the results? We found that even after the extreme heat, the cycling up and down, the oil held up so well that you could put it back in the motorcycle for continued use.